A very good morning, my dear students. Let's continue the topic called river boat and rain man concepts. Today we'll focus, special focus on numericals also will be there. Let's look at the previous class, a quick recap, all right? Not in detail, a quick recap. In detail analysis we have done in the last class. Have a look at here. There is a river. The width of the river, what we had written was t. So this is the velocity of the water with respect to ground. Here in the same direction of water, if the boat is moving, this is the velocity of the boat with respect to water. Then the concept of downstream we had already discussed. Downstream means in the direction of the water if the boat is moving. In the downstream, velocity of the boat with respect to the ground. That means for the person who is observing from the ground, the velocity of the boat with respect to the ground will be equal to velocity of the boat with respect to water plus velocity of the water with respect to ground. In the same case, if the velocity of the boat with respect to water in this way, so then that's called, these are the magnitudes I'm talking, my dear students. These are the magnitudes, all right? So these are the magnitudes. I'm not writing in the vector form. In the vector form, we had discussed in the last class. If it is in the upstream condition, VBG, velocity of the boat with respect to the ground, will be equal to velocity of the boat with respect to water minus velocity of the water with respect to ground. And you can see these are the two important expressions we have got. In the same way, river boat concept, when a man or a boat crossing the river, it can cross in two different ways. That also we have discussed. So it can cross in two different ways. And let's have a look at the number one. Number one is the shortest path. Number two is the shortest time. I hope you can remember this one. I hope you might have recollected. So this is the point A and this is the point B. So the aim of the boat is to move from point A to the exactly point B, right? While moving from A to B, because of the river flow, definitely the boat will move to somewhere in this. So in this case, there's no possibility of moving the boat in the shortest path. So to move the boat to reach the shortest path, it must start in this direction. So that is the velocity of the boat with respect to water. Again, I'm telling you, this velocity of the boat with respect to water is, look at here, velocity of the boat with respect to still water, my dear students. With respect to what? Still water. Remember, this is the assumption. Okay. Now, so this is the velocity of the boat with respect to water, and this is what the velocity of the water with respect to ground. And you see the resultant of these two will be velocity of the boat with respect to the ground. which is observed by the person who is sitting on the bank of the river. Okay, so this is an angle theta here. This velocity of the boat with respect to water must make an angle theta with the vertical. Then only there is a possibility of moving from A to B directly. Okay, so that means initially velocity of the boat must make an angle this 90 plus theta, right? So finally to reach the point P. With the flow of water, it should make 90 plus theta angle. With the vertical, it should make theta angle to move in the shortest path. So in this shortest path, in this shortest path, what we have discussed, VBW square, which is equal to VWG square plus VBG square from the Pythagoras theorem. Okay, so VBG square is equal to VBW square minus VWG square. Okay, from here you can write the square root of. In this case also there is some time taken by this boat to move the point B. So that is equal to, this is the width of the river, right? So time is equal to the distance traveled by the speed along that distance. Speed along this distance is how much? VBG. That VBG expression you have just found from here. All right. This is the shortest path, not more than this. Fine. Now the shortest time. So simple. See, particularly starting from here, point A is here, point B here. Shortest time means the aim must be like this. So this is velocity of the boat with respect to water. Because of the velocity of water in this direction, so boat will reach to some point C here. This is the velocity of the boat with respect to ground, and this is the velocity of the water with respect to ground. Okay, see here, this is called the drift. What is this called? A drift. So here the important thing will be velocity of the boat with respect to ground whole square is equal to velocity of the boat with respect to water whole square plus velocity of the water with respect to ground whole square. Okay, so here the important concept is the minimum time. That's our topic, right? Minimum time. Minimum time is equal to distance by the speed in that distance, right? So V B W. Okay, so now here comes another important topic, the drift. So drift is equal to x. Because of the flow of water there is some drift here. The drift is equal to speed into time. What is the speed in this direction, in the direction of the drift? So VWG into time. So what is the time here? So that is the minimum time. It's called the shortest time. So the drift x is equal to VWG into T minimum is D by VBW. That's it, right? These are the areas. And here also, by the time it reached to the final point C with the drift x, the theta will be here. This theta. So this theta also you can find, for example, if it is tan theta, opposite side, that is x by, and adjacent side, so that is d t. So the same tan theta can also be written as opposite side velocity is VWG by adjacent side velocity is VBW. The same thing we can write. Here also the sine theta, we can write sine theta is equal to opposite side is VWG by hypotenuse is VBW. In this way, right? Clear? Let's look at the basic and the little advanced level problems in this case. Let's see two problems, two numericals on this, because we need to finish the Rain Man concept also along with the numericals today, right? Let's have a look at this example numerical. The question is, a person reaches a point directly opposite on the other bank of a flowing river while swimming at a speed of 5 meters per second at an angle of 120 degrees with the flow of water. The speed of flow must be. Have a look at this question. A person reaches the point directly on the opposite on the other bank of the flowing water. So this is the rough diagram. Always if you could make the rough diagram, and it will be very easy for you to understand this concept. Person is directly reaching here. Reaching here means it is definitely a shortest distance case. Will you agree with this? This is definitely a shortest distance condition is given because a person is reaching exactly on the opposite point. If it is shortest distance case, definitely you should not move in this direction. Okay, you should start moving in this direction. So what is that? This is velocity of the boat with respect to what? With respect to still water. At some angle he must start. Okay, so let's see. This is the complete VBW and this is complete VWG, velocity of the water with respect to ground. Now, look at here, my dear students. Theta. Here, while swimming at a speed of 5 meters per second, he is swimming with a speed of 5 meters per second here. At an angle of 120 degrees with the flow of water. See, this cannot be 120, it is less than 90, right? So, the flow of water is this one. This is the flow of water. This can also be written as velocity of the water with respect to ground. Okay, so this vector and this vector is same. Now, if you really understand the topic here, this velocity of the boat, see here, a person reaches a directly opposite on the other bank of the flowing water while swimming at the speed of 5 meters per second. See, in the place of boat, in this numerical, we are keeping a person. That's it. Understand? So here, this velocity of the person initially is making an angle 120 degrees with the flow of water. That is the question. And the speed of the flow they are asking. Speed of the flow. Speed of the flow is, this is the question they are asking. Right? So simple, my dear students. If the total angle is 120 and this is 90, and what is this theta? So this theta must be 30 degrees. So simple. Right? So because this theta expression we have, for example, if you could write sine theta is equal to opposite side is velocity of the water with respect to ground divided by hypotenuse. Hypotenuse is VBW. Okay. Sine 30 degrees is 1 by 2. which is equal to velocity of the water with respect to ground divided by velocity of the boat with respect to water is 5. So this is VWG is equal to 5 by 2, which is equal to 2.5 meters per second, my dear students. All right, clear? So velocity of the water with respect to ground is how much? 2.5 meters per second. Clear? So that's it. So in this way, the numericals will be asked. So no confusions. Here in the place of boat, we are keeping the person because it is a man river. It's not the river boat. Okay. That's it. Let's have a look at the another question so that your confidence will be developed. Another question. Another question is the speed of a boat is the speed of a boat is 5 kilometers per hour in still water. If it crosses a river of width 1 kilometer along shortest possible path along the shortest possible path in 15 minutes. The question is the velocity of river water in kilometers per hour they are asking. Let's read the question. The speed of a boat is 5 kilometers per hour in still water if it is crosses a river of width 1 kilometer along the shortest possible path. This is also the similar condition, shortest possible path. The rough diagram I'm making. So this is the point A and this is the point B. The aim is to move from A to B, but it must start in this direction somehow. Okay, so this is the aim. Velocity of the boat with respect to water must be like this, right? This is the velocity of the water with respect to ground, and this will be velocity of the boat with respect to ground. Okay, so now it is making the shortest possible path in a time of 15 minutes, my dear students. The velocity of the river with respect to what? Velocity of the water with respect to ground, we need to check. Given data, speed of the boat is 5 kilometers per hour in still water. I told you already, speed of the boat is 5 kilometers per hour. So that is 5 kilometers per hour is given, my dear students. Okay. Now, everything is in kilometer per hour we need to make because the answer we need in kilometer per hour. So this in terms of hours you can make it is 15 by 60 hours. So this is 1 by 4 hours. Now, how to find this velocity of this? We know in this case time taken will be, all right? So what is the time taken in this case? It is distance by the speed in this direction, right? So speed in the direction of displacement. So VBG. So here 1 by 4 is equal to D is 1 kilometer, my dear students. Everything is kilometers per hour. This is kilometer by VBG. Okay. So from here what I can write? So VBG is equal to, it is 4 kilometers per hour. So simple, you can see. So this is 4 kilometer per hour and the previous one, so this is 5 kilometer per hour. So now you can find VWG, right? So by using Pythagoras theorem, by using Pythagoras theorem. What happens by using Pythagoras theorem? So VBW, velocity of the boat with respect to water, whole square is equal to velocity of the boat with respect to ground square plus velocity of the water with respect to ground whole square. So VBW square, its phi square is equal to velocity of the boat with respect to ground, that is 4 square, plus velocity of the water with respect to ground whole square. It is 5 square minus 4 square, 25, minus it is 16 is equal to velocity of the water with respect to ground whole square. So this is 9. So velocity of the water with respect to the ground will be equal to 9 kilometers per hour, my dear students. It's 9 kilometers per hour. Right? In this way, questions will be asked. So let's have a discussion based on a rain man. Concept and numericals. Concept and numericals. A rain man topic is a more interesting than the river boat. How it is more interesting? You can see. This is the ground. Imagine actually there is a rainfall in this direction, vertically downwards. Actually there is a rainfall vertically downwards. See? This is the actual rainfall. So simple concept, actual rain. Now let me take the another case. This is the graph. So there is a person here who is at rest. Okay. So there is a rain. As the person is rain, in order, carefully see, in order to avoid the rain, he need to hold the umbrella in this way because he is at rest. You know, the rainfall is in this direction. This is the direction of the rainfall as it is. Okay. So this is the rainfall direction. See, there's no difference in the first case and second case. As the person is at rest, in order to save him from the rain, he must carry his umbrella in this. I hope first case and the second case you understood. Third case is the most important case. This is the ground. You might have felt the same situation. Imagine this is the man is running. This is the man is running or moving in a bicycle or a cycle or in a car, whatever it may be. Not a car, any moving object he is inside. Now, in which direction he should hold his umbrella to avoid the rain? That's a question. In which direction he should hold the umbrella to avoid the rain? For example, imagine a situation, he is holding the umbrella in this direction like the previous case. Will he get wet or not? Will he get wet or not? Tell me. So definitely he will get wet because when he is running in this direction, definitely for him the rainfall is in this direction. For him the rainfall will be in this direction. Definitely he'll get wet. Why it is happening? So there is so many internal phenomena behind this. So we are not going into the internal phenomenon. So the internal phenomenon is the wind effect only. No confusion, right? The internal phenomenon is the wind effect. Because of the wind effect, it will happen in this way. But to avoid the rain in this case, this person must hold the umbrella in this way, my dear students. This is the ground. This person who is moving in this direction, who is running or cycling or in a scooter, so he must hold the umbrella in this direction to avoid the rain, because the rainfall will be in this direction, right? Okay, but at the same point there is another man who is at rest. For him the rainfall will be straight as, see the difference. So if the person is at rest, the rainfall will be as it is actual rainfall. If a person is moving, the rainfall is like this. That means with respect to man, rainfall condition is varying according to his velocity. This is the velocity of the rain with respect to the man. This is also velocity of the rain with respect to the man. But actual velocity of the rain is here, my dear students. The velocity of the rain is in this way. All right. Clear? Is it simple? It is so simple condition. So velocity of the rain with respect to man, which is equal to velocity of the rain minus velocity of the man. So this is the one and only formula. This is in the form of VAB bar, which is equal to VA bar minus VB bar. That's a relative velocity formula. Velocity of the rain with respect to man, which is equal to VR bar minus VM bar. Velocity of the AB bar is equal to VA bar minus VB bar. This is the formula of the relative velocity. No confusions. So the complete concept of this river rain man situation will be based on this formula only. So there are so many cases here. There are so many cases, and let's talk about one by one. So many cases involved here. Let's look at this case. Case 1. Case 1 is, so this is the ground. This is the velocity of the rain, actual velocity of the rain. A person is moving in this direction. This is the velocity of the man. Carefully see. Definitely for him, velocity of the rain will not appear in a straight line, right? Not in a vertical form. Yes, sir. For him, as the person is moving, velocity of the rain will not appear vertically downwards. Okay. In which direction it appears? In some other direction. So the question is, at what angle he should hold his umbrella such that he could avoid the rain, right? So at what angle he should hold the umbrella. So before moving into the concept of angle, we know velocity of the rain with respect to man, that is what our aim. So this is equal to velocity of the rain minus velocity of the man. This I can also write it as velocity of the rain with respect to man is equal to velocity of the rain plus minus velocity of the man. This is from vector laws of addition only. Velocity of the rain. So this is velocity of the rain. All right. Minus velocity of the man. See, this is velocity of the man. So this is the negative vector of this. So this is minus velocity of the man. Velocity of the rain plus this vector. So this vector and this vector, you can see here the vector loss of addition. So these two vectors are in the order now, my dear students. This VR bar and Vm bar minus Vm bar are in the order. So now we are closing the triangle. This closed side will gives you the resultant vector Vrm bar, which is equal to Vr bar plus minus of Vm bar. See here, that is velocity of the rain with respect to man. All right. Clear? So this is the angle he should hold the umbrella so that to avoid the rain. So what is that angle? Tan theta is equal to opposite side, the magnitude. This is negative sign indicates the direction. Magnitude is Vm by this is Vr. Tan theta is equal to Vm by Vr. In this case, if the rain actually falling vertically downwards, right? If the rain actually fall vertically downwards, this is the condition, my dear students, vertically downwards, if it is actually falling. If not, the case is different. If not, definitely the case will be different. Right. Here also Pythagoras theorem you can apply, my dear students. So Vrm square, which is equal to Vr square plus Vm square. Pythagoras theorem you can apply if you want some value here, right? They may give you this one and this one. They may ask you to find this. You can do that. But majority of the times the question will be asked this one. What angle he should hold his umbrella such that he could avoid the rain? Okay, clear? So let's have a discussion, a numerical based on the same question number, same based on the case. The question is, a car with a vertical windshield moves in a rainstorm at a speed of 40 kilometers per hour. The raindrops fall vertically with a constant speed of 20 meters per second. The angle at which the raindrops strike the windshield is. Same situation, same situation. So there is no confusion at all. Don't think that it is some other case. A car with a vertical windshield. So this is the car, for example. Imagine this is a car or a van, whatever it is. This is the windshield, okay? It's moving with a speed of 40 kilometers per hour. The rain drops vertically with a constant speed of 20 meters per second. You can see here. This is a velocity of the rain, my dear students. Velocity of the rain. If a car is moving 40 kilometers per hour, so this here you can see the car is moving with 40 kilometers per hour, velocity of the car. Here we need velocity of the rain with respect to car, which is equal to VR bar minus VC bar. So this I can also write it as VR bar plus of minus VC bar. Okay, so this is VR bar, this is plus VC bar, right? So if I write the negative vector of it, that will be minus VC bar. Okay, so this is VR bar. So now you can draw the resultant here. This is VRC bar. So there is an angle here, you can see. That is angle. So this is the angle theta, tan theta, which is equal to VC by VR. VC by VR. Here, carefully see the same situation. This is the theta. If it is theta, this is also a theta. Okay, this one. These are theta. This is theta and this is theta. Now, with the vertical, the angle at which the raindrops strike. So this is the raindrop striking. This is velocity of the rain with respect to, this is VRC. Okay, so this is the theta they are asking. What is this theta? This is equal to this theta only. So VC, what is VC? VC, velocity of the car, which is 40 kilometer per hour. This is 40 into 5 by 18 in meter per second. I wrote that. Velocity of the rain, it is 20 meters per second. So this is 0 0 and this is 2 2s, 2 5s, this is I can say 2 9s. So tan theta is equal to 5 by 9, my dear students. Okay, so then from here I can write theta is equal to tan inverse of 5 by 9. All right, theta is what? Tan inverse of 5 by 9. Clear? This way the numericals will be asked. Let's have a look at another topic like case 2. In case 1, what we discussed, actually rainfall is in this direction. This is velocity of the rain. For the person, it appeared in this way. This is velocity of the rain with respect to man. Now, this is the velocity of the rain, my dear students. This is the velocity of the rain. Initially itself, with the vertical, it is making some angle theta. This is velocity of the rain. If a person is moving with some velocity, if a person is moving with some velocity, this is velocity of the man. Okay. In this case, what is the velocity of the rain with respect to man? Wherever the formula remains same, velocity of the rain minus velocity of the man. This is velocity of the rain, so this is velocity of the man, isn't it? See, minus velocity of the man. So in this case, you can find the velocity of the rain with respect to man will be like this, right? So this is VRM. Here, so the total angle, this is theta. Imagine if it is x here, this is y here. The total angle, I can say tan theta is equal to x plus this is tan theta is equal to, there is a right angle triangle is formed here. You can see there is a right angle triangle. That right angle triangle I'll write in detail. In a detailed way, I'll draw the right angle triangle. Right. See the right angle triangle here. This is the theta, right? So this is y and this is x. See, this is x, this is minus Vm. Okay. Here tan theta is equal to this x plus, this is the magnitude, this minus Vm bar is a vector, so magnitude is just Vm by y, x plus Vm by y. For example, if this is alpha, tan alpha I can write x by y. What is this condition here? This is the last topic of this rain man. This is little advanced topic, and listen carefully here. This is the actual rainfall in this case, velocity of the rain with the vertical. Person is moving in this direction, velocity of the man. For him, rain will appear maybe like this, or it may be vertical. Are you understanding? Because if the rainfall is like this, actual rainfall, as he's moving, for him rain appear to be like this. Always rain appears to be like this towards him, not away from him. When the actual rainfall, because of the wind flow, the actual rainfall may be in this way. Because of the actual rainfall, carefully see, the rain appeared to be in this direction for him. Rain appeared to be in this direction for him. See, this is what the velocity of the rain with respect to man. All right, clear? And there is a last case. If this velocity increases, what happened, you know? If it is velocity of the rain, actual velocity with a vertical, man is moving like this. This is Vm. So this will be the V minus Vm bar. This is Vr bar. You can write now, this is Vrm bar. So what does it mean? As the velocity of the man is increasing, at some point, at some angle, definitely velocity of the rain with respect to man is straight, because he'll feel that at this point, he'll feel that, depends on this velocity, my dear student, depends on this velocity. At a particular point, he feels that the rain appears to be straight. If the actual rain is falling straight vertically downwards, if he is moving, it will appear to be at a slanting angle like this. But here, rain actually falling in some angle with a vertical. As he is moving so fast and little fast, at some point there is a possibility of he may feel that the rain is falling exactly vertically downwards. This way, the questions can also be asked, my dear students, right? So the river man or the river boat and rain man, numericals and concepts with the higher level is done. Understand? Next class, we'll solve some numericals, on relative velocity, my dear students, right? And including these topics, last two classes topics, right? All the very best.